Hello friends, hope you are doing good. Welcome to the fifth practice set of the SAT series. Let's get started here. So we have a two-digit number and the sum of the digits is 7, and when we reverse the digits then the number increases by 9 and we have to find the number, right? Okay, so let's say that the two digits are x and y, right? So x and y. So this is the units digit and this is the tens digit, correct? The sum of the digits is 7, so x plus y is equal to 7, right? So that's a straightforward equation, x plus y is equal to 7, right? Now remember, this is the units digit and this is the tens digit, right? That's what we assumed to begin with. Now when we are reversing the digits, the number is increasing by 9, okay? So how can we write the original number, right? The original number is essentially y plus 10x, right? Because y is the units digit and x is the tenth digit. So y plus 10x, right, will be the original number. Let's say that if we have to write 24, correct? How do we write 24? 4 plus 10 times 2, correct? 10 times 2. So 4 plus 20 is equal to 24, correct? So with that logic, we are saying that the original number will be something like this, right? This will be the original number. Now when we are reversing the digits, y becomes the tens digit and x becomes the units digit. So the number will become x plus 10y, right? This will be the reversed number, correct? As per the question, this reversed number is 9 more than the original number. Hence x plus 10y is equal to y plus 10x plus 9, correct? So our second equation will be 10y plus x is equal to the original number plus 9. So 10x plus y plus 9, right? And we bring the similar variables on one side, so it becomes kind of 9y is equal to 9x plus 9. I mean, I brought y to the left side, I brought x to the right side, and then we can divide by 9 on both sides to get y is equal to x plus 1. So this is our second equation. So this is our second equation and this is our first equation, correct? And then we can solve them by substitution in this case to find x and y. And when we do that, right, let's say, so y is equal to x plus 1, so I can write x plus 1 is equal to 7, or 2x is equal to 6, or x is equal to 3. So the original tens digit would be 3, and we can substitute the value of x here back to get the value of y. So we get y is equal to 4. So the original number would be 34. So 34 is our original number, and as we see, once we reverse the digits, it becomes 43, which is 9 more than 34, right? So 34 is the number. Question number 2. 8 to the power of 4 by 3 times 8 to the power of minus 8 over 3 is equal to 1 over 2 to the power of m, and we have to find the value of m, right? So the first thing which comes to our mind is that there are these two terms, right, which are being multiplied and they have the same base, right? 8 is the base here and 8 is the base here. And we know that when we are multiplying two terms with the same bases, the powers get added, right? So this left side will become 8 to the power of 4 over 3 plus of minus 8 over 3 is like minus 8 over 3, which will be equal to 8 to the power of minus 4 over 3, right? So this is our left hand side, okay? Let's write it here. So essentially we have got 8 to the power of minus 4 over 3 is equal to 1 over 2 to the power of m. Correct. Now, we have seen in the past that to deal with questions like this, we have to think that we have to make the same bases on both sides, right? We have a base of 2 here, so we can try to transform the left side in such a way that we can have the base 2 here, and when we think on those lines, we notice that 8 is nothing but 2 to the power of 3, correct? So 8 is nothing but 2 to the power of 3, right? 2 times 2 times 2 is 8. So instead of 8, we can write 2 to the power of 3 and to the power of minus 4 over 3, correct? We're just writing 8 as 2 to the power of 3. This minus 4 over 3 was always there, this power, so this is all here. Now when we are looking at this one, right, the powers get multiplied. When there is a power to the power, the powers get multiplied. We know that as well. So this will become 2 to the power of minus 4, right, because 3 and 3 get cancelled. Or we can say minus 12 over 3, which is again 2 minus 4. So basically the left side becomes 2 to the power of minus 4. 2 to the power of minus 4 is the same as 1 over 2 to the power of 4, right? So we can do the reciprocal of that and make this power positive, correct? So we have done some transformations here, and we're trying to replicate the left side in such a way that it looks similar to the right side, correct? So by doing all of this, our left side finally becomes this, right? Right side is already 1 over 2 to the power of m, correct? Hence, m is nothing but equal to 4. So m is equal to 4. Just to quickly reiterate, all we have to do in such questions is that we have to play in such a way that we make the same bases on both sides. When the bases are same, then we can equate the powers. That's what we did here, and m came out to be 4. Next question. Fx is equal to minus 2x square minus 4x plus 7, and we have to find the vertex of this parabolic function, correct? Now, this function is in the standard form. Standard form is nothing but ax square plus bx plus c, correct? And we know that when a function is in the standard form, the x coordinate of the vertex is given by minus b over 2a, right? This is the x coordinate of the vertex, right? When the function is in the standard form. So pretty straightforward. We know our a, we know our b, we know our c. We can just find the value of minus b over 2a. Let's do that. So the x coordinate of the vertex would be given by minus b over 2a. B is minus 4, so minus b would be 4 over 2a. Our a is minus 2, so 2 times minus 2 is minus 4. So it's minus 1. So this is our x coordinate of the vertex, correct? The a is negative, so it means that the parabola will be opening downwards, hence it will have a maxima, right? It will have a maximum vertex. So the shape of this parabola would be something like this, right? It will be opening downwards because a is negative. So this parabola will have a maxima point, not the minimum. And that's what we're trying to find. So the x coordinate of the vertex is minus 1. To find the y value or the y coordinate of the vertex, we'll just plug in this value of x here and find the corresponding value of y. That's what we do, right? If we have a function and we have to find the value of the function at any specific value of x, we plug in that value of x and compute the corresponding value of y or the value of the function. So let's just plug in here, and the y value of the vertex would be minus 2 times minus 1 square minus 4 times minus 1 plus 7, which is minus 2 because minus 1 square is 1 plus 4 plus 7 or 9. Hence the vertex would be minus 1 comma 9. Question number 4. 2x to the power of minus 1 times y divided by x to the power of minus 3 times y to the power of minus 2, entire fraction to the power of minus 3, right? We have to rewrite this expression such that it contains only positive exponents, okay? So right now there are a lot of negative exponents all over the place. We have to transform this in such a way that we should have only positive exponents or only positive powers, right? Okay, so when we look into this, the first thing is to kind of simplify this whole thing inside the parenthesis, right? Before we think about this power, we can simplify this whole thing, correct? So 2 is in the numerator, so it continues to be like this. Now, we know that when the two terms are divided having the same basis, right? For example, you have a to the power of m divided by a to the power of n, right? You have two terms with the same base, the powers get subtracted. So it's like a to the power of m minus n, correct? The same thing we are going to do here. So for this portion, right, it will be x to the power of minus 1 plus 3. X to the power of minus 1 plus 3. Correct? Because this is our m and this is our n. So minus of minus 3 is plus 3. So it becomes plus 3. And the same thing we are going to do for the y as well. So it becomes y to the power of, this is like y to the power of 1. Right? So 1 minus of minus 2 is 1 plus 2. Right? And everything to the power of minus 3. Okay, let's simplify this inside here. So this becomes 2 times x squared, minus 1 plus 3 is 2, and this becomes y cube, 1 plus 2 is 3, correct? Right. So we see that the whole thing inside the parenthesis is already coming out to be the positive powers, just by chance here. But anyways, we have simplified this portion here. Now we are going to take care of this power, right? And we know that when we expand this power has to go to each of the term. So this power of minus 3 has to go to 2, it has to go to x, and it has to go to y also. So it becomes 2 to the power of minus 3, and these powers get multiplied. So x to the power of minus 6 and y to the power of minus 9. Correct? The powers get multiplied. Now, since we have to keep only the positive exponents, we're going to do the reciprocal of each of these so that all these powers become negative. So it becomes 1 over 2 to the power of 3, x to the power of 6, and y to the power of 9. And we can further simplify that because 2 to the power of 3 is 8. So essentially it becomes 1 over 8, x to the power of 6, and y to the power of 9. So this becomes our final answer. In this, all the powers are positive as what they were looking for, right? So just to quickly reiterate, we simplified this expression inside the parenthesis first, whatever it came out to be, and then we gave this final power to each of the terms and saw what we got, and then we did the reciprocals as required to make the powers positive, right? And we get 1 over 8x to the power of 6, y to the power of 9. This is a transformed function which is having only positive exponents. Question number 5. X square over 6 minus 2x over 3 minus 5 over 2 is equal to 0. So we have a quadratic equation like this, and we have to find the product of the roots or the product of the solutions of this quadratic equation. Right, so one way of doing this would be to actually find the solutions of this quadratic equation and then multiply the two solutions and get the product of the roots. However, the faster way could be, as we know that if we have a quadratic equation like ax square plus bx plus c is equal to 0, right, in this form, then actually the sum of the roots is given by minus b over a, and the product of the roots is given by c over a, correct? So these are kind of two shortcuts which we can use in case they're asking us to find the sum or the product. They're not asking us to find the actual roots. We can also find the actual roots, but if the ask is only to find the product, then as long as we know c and a, we can use this to get the product. It's as simple as that, right? So in this case, let's go ahead and use this shortcut here. Our c, the value of c is minus 5 over 2, right? The value of a is 1 over 6, correct? Not 6, 1 over 6. So the product would be C over A, which is minus 5 over 2 divided by 1 over 6. And when you simplify these fractions, you get minus 5 times 6 over 2, because 6 goes on the top. It's like minus 15. 2 times 3 is 6, and 3 times minus 5 is minus 15. So directly within a few seconds we get that the product of the two roots of this quadratic equation would be minus 15. We can always keep them handy, and they are very useful, because imagine if you have to find the solutions of this, you will have to do some things here and put some time and energy to find the actual roots and then multiply them. We don't need to do that. We can directly use C over A to get minus 15. We have a circle with center O. PQ is the diameter, obviously passing through the center O. The coordinates of P are minus 4, 6, and that of Q are 8, 10. And we have to write or find the equation of this circle, right? Now, before we get started, obviously we need to understand that how the equation of the circle looks like. We know that there are different forms of equations for a parabola, right? We talked about the vertex form, the standard form, and the roots form. Similarly, we need to understand, first of all, how is the equation of a circle. So the equation of the circle is given by this: x minus h whole square plus y minus k whole square is equal to r square, where h comma k are the coordinates of the center and r is the radius, right? So essentially, if we have to write the equation of the circle, we need to know the coordinates of the center, and we also need to know the radius. Once we have those items, we can plug in them here and get the equation of the circle. So let's get started here, right? So the coordinates of P and Q are given, so we can find the length PQ, right, by the distance between the 2 points formula. So the length of PQ would be, right, y2 minus y1 whole square plus x2 minus x1 whole square. So 8 minus of minus 4 is 12. So 12 square plus 10 minus 6, which is 4 square, which is equal to square root of 144 plus 16, which is equal to square root of 160. So square root of 160 is the length PQ, right, the diameter. Obviously radius would be half of that, so the radius would be square root of 160 divided by 2. So we have got our radius, whatever that is, but our radius is square root of 160 divided by 2, correct? Now let's go ahead and find the coordinates of the center. Now center obviously is the midpoint of the diameter, so we can use the midpoint formula to find the coordinates of the center O. So the x coordinate of O would be the average of the x coordinates of the endpoint. So minus 4 plus 8 divided by 2, right, which is equal to 2. And the y coordinate of the center O would be 6 plus 10 divided by 2. We're just taking the corresponding averages, right? So 16 over 2 is 8. So we got the coordinates of the center also, it's 2, 8. So this is nothing but 2, 8. You can plug these points here to get our equation of circle. So it will be x minus 2 whole square plus y minus 8 whole square is equal to square root of 160 divided by 2 whole square, correct? Our h is 2, our k is 8, and our r is square root of 160 divided by 2. We're just plugging it here, and then we can simplify this, right? So this will be nothing but, it will become 160 divided by 4. So this will be 160 divided by 4, right? Which is nothing but 40. So this becomes the equation of this circle. Hello students, hope you liked the video and you found the examples meaningful and useful. Keep practicing, do like and subscribe. See you in the next session.